This session we will see about deadlock recovery. Whenever system falls into deadlock, then operating system interferes and try to recover the state from the deadlock. How this is happening? This is happening by imposing some special constraints to either to kill the process to get the resource back. So there are the two different varieties of mechanisms are there to recovery from the deadlock. So deadlock recovery is the process remove the deadlock once it is detected. Once the system identifies deadlocked processes, it takes corrective actions to break the deadlock and restore normal execution. So there are two varieties of recovery methods. One is a process termination. The other one is abort one process at a time. So process termination. Process termination is nothing but terminate one or more processes who are involved in the deadlock. Method 1. Abort all deadlocked processes. Whoever is involved in order to form the deadlock, then remove them. So abort all the deadlocked processes. For example, if there is a cycle between P1 and P2 and P3, then immediately we will understand that the deadlocks are detected here. When deadlocks are detected, the process cannot move further because they bound to each other. Then in this case, what happened? The operating system itself to remove these cycles. That is, one of the method is abort all deadlocked processes. Here, when we abort these processes, then whatever the edges are there in between them going to be removed, then there will not be any concept of deadlock further. So here what we did is forcefully we are trying to kill the processes even though they are busy in what I mean to say execution. But here in execution never happened because they are formed deadlock and try to request each other. It is a never ending process. So in this case, we will terminate P1, P2 and P3 because they are involved into deadlock. Advantage is it is very simple and quickly removes the deadlock, but it is a very expensive. If the processes are currently running, then you are trying to kill them, then you're going to see that uh, the saved work is going to be undone. So whatever the work is done so far, that has to be rolled back. So loss of completed work and expensive, the process becomes a very larger. For example, you see, I have downloaded a movie which is downloaded 90%. Suddenly it has got deadlocked. Then in this case, if you terminate that particular process, 90% of the downloading is completely abandoned. And so instead of that, better you terminate one by one process at a time. One by one process means you choose because out of the three processes, if you remove cycles, at least one or two among, then deadlocks can be removed itself only. So in this case, what happened? There is a cycle among them. Instead of killing all these three, better you kill one process. Then what happened? This edge is broken and this edge is also broken because this process is not there. And in this case, the rest of the processes are P2 and P3. They are live. So instead of killing all the processes, better you choose which of the process you would like to kill it. So that depends upon different criteria. So while killing the process, you need to choose that which process is occupied more number of resources, you kill them, and which process is just initiated, then you kill them. But don't kill the process which is in the middle of the download or middle of the completion. Don't kill them. So that's what either kill all the processes, but it is expensive, or kill one process at a time. The process selection criteria. Lowest priority process can be killed. Least execution time is completed, so you can also kill it. Fewer resources held, you can also kill. And least cost to restart, you can also kill. Then the second method, the second alternative in order to recover the system from deadlock is resource preemption. What is the resource preemption? So let us see, we will form a deadlock here. There is resource R1, which is sharing between two processes like P1 and P2, and they formed like this. R1 is given to P2, P2 is requesting for R2, R2 is given to P1. There is a cycle happen. In this case, we will preempt the resource. Earlier method is, it is targeting process, but this method is targeting resource. So if you kill that resource, the cycles are getting to be removed. Then deadlock cycle is removed. So take a resource away from some processes and allocate them to others. So steps are: select a victim, choose a process whose resources can be preempted, and preempt resources. Take resource R1 from P1 and give to P2. So this is a one way. And step 3 is a rollback. Return the victim process to previous safe state and restart the process later. For example, P1 holds resource R1 and needs R2. So let us form a cycle here. P1 holds resource R1. P1 holds resource R1 and needs R2 and needs R2. That R2 is already allocated to some other process. That R2 is allocated to P2, and P2 requesting for R1. So there is a cycle. In this case, we understand that there is a cycle formation and deadlock occurred between P1 and P2. So we will recover it. Take R1 from P1. So take R1 from P1. This one is completely removed. Take R1 from P1. That means instance of R1 has come now. It is free now because R1 is removed from P1. So R1 is available. This freely available R1 can be given to P2. Now P2 can run happily by taking the resources from R1 and by taking the resources from R2. Now P2 can be executed happily. So once a P2 is completed, then P2 releases back. P2 releases R1 back and P2 releases R2 back because P2 is successfully completed. This is how you can able to remove deadlocks. Once they have released back, and these resources can be given to process P1 afterwards, and process P1 also can able to execute it. So issues in recovery: starvation. Because you are getting the resources from the earlier process, then process will be always under what? Waiting for the resource. For example, according to previous case, we have revoked back resource R1 from P1. Earlier it was initiated. Now I have removed this. Once I have removed, then this R1 is assigned to P2 according to our case. P2 already obtained resource R2 in this case. As you have removed it, we have removed R1 from P1. Then in that case, P1 becomes what? Idle. P1 becomes idle. It is waiting for same R1 and R2, but operating system forcefully remove R1 from P1 and assign it to process 2. So in this case, P1 is going to be under waiting state. That is the meaning of what? Starvation. And the solution is, keep track how many times a process has been selected as a victim to avoid choosing it what? Repeatedly. If this is happening every time to so same process, next time we will give a preference to that process by increasing the age. Therefore, that process request also can be accommodated. This is how we can able to recover a system from deadlock. One is preempt what? Resources. The other one, killing of the processes. Killing of the process, two varieties: either kill all the process or kill required process. Just our intention is remove what? A cycle among the processes.